So today we're going to factor. All right. So and then ideally so we'll start this one today. We'll have day 1 today. We'll factor. Then we'll pick up day 2 next week Monday with more factoring, and we'll get into solving. And then it's basically going to be a solving week after that. And then we'll get into higher level solvings and all that fun stuff. Okay. All right. Here we go. So there's 5 keys to factoring. Okay? We're going to do 4 of them today. Okay? We'll do the 5th one next week, Monday. We'll bring that in. I didn't have time this morning in the first class to get it in today. So we'll do 4 of them today, and then we'll hit the last one next week. Okay? So the first thing that you should do is, and the nice thing about it is you should kind of do these in this order. That should be your kind of checklist for factoring every single time. Okay? All right? And so the first thing that you should do is you should GCF. You should look for the greatest common factor. Okay? The biggest term that evenly goes into all of the terms in your polynomial or your polynomial equation. Okay? So I look at numbers. Okay? So there are 2 parts to this. There's the number part, where you look for the biggest factor. Of all the numbers. Okay? So if I'm looking at 8 and 20, what's the biggest number that goes into both of those? 4. Okay? So 4 would be my greatest common number factor. Well, that's good. Okay? Then, for variables, first off, there has to be the same variable in all terms. Okay, so that's the first thing. The variable has to show up in all of the terms in order to GCF it out. And then you take the smallest exponent out. So looking at x squared and x, both terms have an x in it. So that satisfies condition number 1. And the smallest exponent is 1. So we're only going to take out 1x. Okay. Then that leaves over something. And now you ask yourself, what times 4 gets me 8? 2. Okay? So then this one is going to be 2. What times x gets me x squared? X. So this first term in the parentheses is going to be 2x. The sign, the operation in between them, doesn't change unless you factor out a negative. Okay? If you factor out a negative, then all of the signs inside the parentheses will become the opposite. Now we go to the next one. What times 4 gets me 20? 5. What times x gets me x? Just 1, right? Yeah, so we don't have to add any more variables there. So then that is my GCF term. Or not term, my GCF expression. Factor. So that's the first one. Every single time you should check to see if you can greatest common factor first. After that, you should look at to see if they are a difference of perfect squares. Okay? Now, again, there are two parts to this one. The first part is the difference part. In math, difference means subtraction. So this sign right here, this operation right in there, has to be a subtraction in order to factor by the difference of perfect squares. Okay? Has to be a subtraction sign. If it's an addition sign there, can't factor by difference of perfect squares. Okay? The next part is that both of these terms have to be perfect squares. Okay? So in terms of numbers, the perfect squares, again, are 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, and so on and so forth. 121 for 11, 144 for 12, 169 for 13, 196 for 14, 225 for 15, and so on and so forth. Okay? So that's for the number. Got to be on that list. Okay? For variables, it has to be an even exponent. Okay? A variable is a perfect square if it has an even exponent. And so you look then at your two terms. Okay? First thing you look for is to make sure it's a subtraction. We got that. Okay? Second thing to look for is you need to make sure that both of the terms are perfect squares. 9 shows up on our list of perfect squares, so it is a perfect square. X squared is a perfect square because it has an even exponent. 1 shows up on our list, so both terms are perfect squares. Okay? If that's the case, then if you have a squared minus b squared, that factors then to be a minus b times a plus b. So you take the square root of each term, so this would really be 3x quantity squared minus 1 quantity squared. So this would factor to be 3x minus 1 and 3x plus 1. Now, let's take a pause for the cause here, halfway through. How do I know that I factored correctly? I can check it by doing what in reverse? Or what would the process be? We'd multiply it, right? You multiply it out, okay? Like we did last Thursday. The double distributive, or on the top one, it's just a straight up distribute. Okay? On the bottom one, it's a double distribute. Okay? So if we multiply through on the top one, we get 8x squared plus 20x, which is what we started with. On the bottom one, we get 9x plus 3x minus 1 plus 3x minus 3x goes away. We get 9x squared minus 1. Okay. Good stuff. Good stuff. Okay. The next one is it's what's called the basic product of two binomials. Okay. That's the fancy math term for what we're doing. Okay. But what we're actually doing here is two sets of parentheses. I call them butt cheeks. Okay? Because it looks like a pair of butt cheeks right there. Okay? Okay? And we just got to fill it. Okay? We got to fill in the two parentheses. So the first two spots come off of those. So what multiplies to be 2x squared? And 2x times 2x is 4x squared.
Oh, 2x times x.
2x and x. We fill in with, are there any other ones? In this case, no, right? So we're good there. The last two get filled in with what multiplies together to be that one. But what multiplies together to be 20? 5 times 4. Any other ones? 10 times 2. 1 times 20. Right? Okay. Any other ones? Huh? And so then you just start trying stuff. Right? So I would try like 4 there and 5 there. Okay? And you multiply these two together, and you get 4x. You multiply these two together, and you get 10x. Together, those two numbers, when I add them together, have to be that middle term. 4x plus 10x, or 4x minus 10x, either add or subtract them. Can I get 3x out of that? Out of 10 and 4? No, I can get 14, or I can get 6. Right? Okay? So that doesn't work. Oh, this is where using a pencil is helpful. Because now we've got to erase. Let's try 5 and 4. Because if they're in a different order, maybe we get different numbers. 5 times x is 5x. 2x times 4 is 8x. Can I get 3 out of that one? Yes. But I got to subtract, right? So which one needs to be negative? The 8x one needs to be negative, right? So I have 5x minus 8x to give me negative 3x. So I need this one to be negative, which means then that this one needs to be negative. And this one would be positive. So this one, in its final factored form, would be 2x plus 5 and x minus 4. Yes, sir. Yep. Can't use this one though, 'cause it's locked. I go down, past the thing by the door.
You have nice things.
Yep, this is why we can't have nice things. Darn sophomores. Alright. Hey, you forgot the pass. Ooh, pop. Pass is hanging by the door for a reason. So when you walk out, you don't get busted by some, teacher that says, "Where's your pass?" You can say that for your hand. Yep. And the last one is cubics. And we will have a whole slide dedicated to this one later on today. Okay? Yeah. The last one is factoring by grouping. And that's the one that I'm going to say for next week. So then that's your 5 total ways to factor something. Okay? All right, let's dive into this. Let's do this. Let's factor these completely. Okay? So if I have 98x minus 14. So if I've got 98x minus 14, first thing I ask myself is, self, can there be a greatest common factor? The answer is, what? Why is there at least one greatest common factor? Because both numbers are even, so at least we have a 2. Okay? Even if we don't see that it's 14 right from the start. Okay? We at least know that there's a 2 because they're both even. So I can for sure factor out a 2. Can I factor out an x? Why not? Second one doesn't have one. So I can only factor out an x if there's an x in every single one of the terms. So right now, the biggest one we have is 2. 98 divided by 2? I know, we know that. We talked about that already. Okay? 49. Yep. 14 divided by 2? 7. Okay? So now you're sitting here. Okay? You factored it, yes. But did you factor it completely, Tyler? Why not? Because there's a what still sitting in both of them? Which one? What is it? 7. Yep, exactly. Because there's a 7 still sitting in both of them. Okay? 49 is 7 times 7. 7 is 7 times 1. So yes, you factored it, but no, you didn't factor it completely. Okay? You said, I'm going to drive to Stevens Point. But you pulled over in Mosinee, you got out of the car and you said, hello, Stevens Point. Okay? Okay? But you're not there. You're on the way there, but you're not there yet. Okay? So we can still factor out a 7. So all told, again, that's why we said at the start, if you didn't see that it was a 14 right from the start, my one got kind of small. There it is, factored all the way complete. Okay. You try letter B. Greatest common factor? 2? Just 2? 2x. Okay. So if I go 2x, what's left over? 6x squared plus 11x plus 4. Okay? Like it? How many people stopped there? Okay, that's fine. That's good. Okay? But what should we check? Well, we shouldn't have any more greatest common factors, right? But then we should check if it's a difference of perfect squares. Is it? No, because it's not 2 terms. then we should check to see if we can trinomial factor it. Two numbers that multiply together to be 6x squared. 2x and 3x? Okay. Two numbers that multiply together to be 4. 2 and 2? Works? No? Okay. Are there another pair of numbers that multiply together to be either 6x squared or another pair that multiply together to be 4? 4? Okay. So let's try the 4 first then. What else multiplies together to be 4? 4 and 1. That gets me 12x and 2x. Is that my pairs? Nope. Okay. But now I can switch those around. That gets me 3x and 8x. Is that what I need? Yep. So what signs go in both parentheses? Both pluses. We need them both to be added together. So all the way is 2x times the quantity 2x plus 1 times the quantity 3x plus 4. Try those two. First one, greatest common factor. What do you got? 5.
Yeah.
That's it? 5g cubed. Yep.
Why did you keep it?
Because the smallest exponent is 3.
Jen. Yes, it does. Is 5 3 is 5 or 3 less?
No, I just need like if you're good multiplier, how do you get 5?
Well, what? Okay, so what am I missing in the first one? What times? What? Do we agree with g plus 16?
No.
No, I don't either. What do you got?
G squared.
G squared plus 16. Not close enough. This is
There's
not
no
horseshoes.
close enough.
Yep. Yep. It is g and g squared are not the same thing. Okay? Can I go any further? Because g squared is a perfect square, yes? 16 is a perfect square, yes? So can I go any further? Why not, Scobie? Why not?
Well, because
Oh, you can't get less than.
G squared is perfect square. 16 is a perfect
if
square.
you do the math, it equals the beginning equation.
I know that, as it should. But I'm saying, can we
So
factor
why
it?
are you not going?
Because I'm asking if we can factor it further.
I don't think that.
In this last one, yes, if I multiplied here, it would got me back to there. But if I also multiply here, it gets me back to the original equation. Because we could factor that other part. So my question is, can we factor g squared plus 16?
Yes.
Why? That's it?
Would you do like 4 and
I understand.
I don't.
You could do like,
Could you just do
Two
G and
parentheses.
G,
Yep,
which equals G squared,
yeah.
yep.
and then
4 and 4. And what goes in between them?
plus.
Both pluses?
Yes.
I don't know.
I don't know.
I feel like we're really big brain a little
But the
Because the
outside
next
is
way is this way, right, to factor? So is it a difference of perfect squares?
Yeah. Wait.
But would the outside stay the
Oh, wait,
same?
this, we're
Would
not
it still be
subtracting.
5?
We're not subtracting,
We're not
so we can't
subtracting.
go any further than this.
Oh my goodness.
Even though it's a perfect square and a perfect square, we can't go any further because it's not the difference of a perfect square. Okay?
So what if we were subtracting?
Then we would go G minus 4, G plus 4.
Okay.
But it's not. You can what? Okay. Greatest common factor, 3x. What's left over? Okay. 25x squared plus 10x plus 1. We should try and see if we can factor that one.
So be-
5x and 5x, you say? Okay. And? Ones and ones? And that gets me, if I go plus and plus, that gets me 10x. Yep. So this one fully factored is 3x times the quantity 5x plus 1 times the quantity 5x plus 1. Yes. Yes. You could also write this one as that. Love it. Yeah. Let's talk cubes now. Okay. Alright. So now space. Yeah. So now we have to look at if it's a cube or not. So we should know what our cube numbers are. Okay? 1 cubed is 1. 2 cubed, 8. 3 cubed, 4 cubed. 5 cubed, 6 cubed, 216, 7 cubed, 64. Sorry, I'll fix it. $343, 8 cubed, 9, 10 is 1,000. Yep. Variables. How do I know that a variable is a perfect cube? What about 3? 3 is a cube. 6 is a cube. 9 is a cube. 6 is not an odd number.
Oh.
It's what? It's divisible by 3, or it is a multiple of 3. Oops, I should say the exponent is a multiple of 3. Now, so this sign right here, this operation, matches this operation right there. Those are both the same. It's opposite those two. And this one is always plus. So it goes same, opposite, plus for your operation. Let's try one. (27x cubed plus 125) is 27x cubed a perfect cube? Yes. Because 27 is on our list of cubes, and x cubed has an exponent that is a multiple of 3. Yes. Is 125? Yeah. Okay. It's on our list. Okay. So this is really 3x quantity cubed plus 5 cubed. Right? So 3x would be my A, 5 would be my B. Following along, we're on the top line because it's plus, so it's going to be A plus B. 3x plus 5. Then, A squared. What's 3x times 3x? 9x squared. Yep, that would be 9x squared. What is the operation? Minus, because it's opposite now, right? Then it says A times B. 15x. Then it says plus B squared. Is? So it's just 25? Okay. Now, you're looking at that trinomial and you're thinking to yourself, we got to double parentheses that one.
Yeah.
But guess what? Nope, because it's never going to be factorable.
Amazing.
Yep. That trinomial right there at the end is not factorable.
I like
So we get that. Yep. I'll get you started on this one because I wanted to get at least one in there where we factor out a negative. Okay? Whenever your lead coefficient is negative and you can GCF, you should GCF out at least a negative 1. And we always want our lead coefficients to be positive. Okay? So if I do that, what is the greatest common factor between those two? 2d squared. Okay? So instead of factoring out a, oops. Oh no, I shouldn't have done that. Okay? So instead of factoring out a 2d squared, I'm going to factor out negative 2d squared. Okay? So what's left over now? What times negative 2 gets me negative 16? 8. How many d's do I need? I need 3 of them. What times negative 2 gets me positive 2? Negative 1. So then this becomes negative 1. Okay. 8d cubed. Is that a perfect cube? Yeah. Of what? Of 2d, right? One. Is that a perfect cube?
Yeah.
Of itself, yep, of 1. Okay. You factor it from there. Yes?
Oh, boy.
Wow.
Okay. Whoa. Wait.
Okay, wait.
Now I gotta cross this out.
So when it's negative 2d squared, and then you distribute that into the 2d, does it just, what is the d become? What's the exponent of the d?
That'd be d cubed.
Oh, yeah, okay. Got it. So then, for the,
What do you mean similar?
It's just such a long process.
I know.
It hurts my brain.
Cubes are.
I have a question. All of this is.
What's up?
Wait, so all of it is
So if I scroll back up, did you write down those two lines? Okay. So if you got them written down, I got them memorized because that's just what I do. Okay. All right. So A is 2d. B is 1. Okay. So it's A minus B. Then this is A squared. 2d times 2d is 4d squared. Then it's plus, because it's opposite. A times B is 1 times 2d is 2d. And then b squared is